everybody. Hope you guys enjoyed your break. Just to catch you up with where we left off. When we last left our heroes, we were talking about some suggested tools to try, right? Again, with the understanding that there are tools that are out there. In fact, just over the break, a couple of individuals came up to me and were talking about other tools like HP Fortify and other tools that are really, really good. The tools that I'm listing here, I chose for one reason. HP Fortify is great. There's Sonar. There's all kinds of wonderful other tools out there. There's one problem with a lot of them, though. They cost money, right? And I'm bringing this in and trying to convince a team and a management chain of the value of it. The less cost to them, the more likely it will get implemented. So what I'm proposing is, if you have the luxury that your management has all this money, your team has all this opportunity to buy things, by all means that's great. Please feel free. If you don't have the money, if you kind of have to prove yourself before you can ask for more money, these might be some tools to try because they're free. They're open source. They're free as in beer. They're free as in
pizza.
Exactly. Free as in pizza. Free as in knowledge. So these are just, again, some tools to try, and my priority, again, why I chose them, I read up on recommended free and open source tools that did what I needed to do. I figured out how to implement them and got that to work. Later on, because I was working for HP at the time, other teams brought in HP Fortify. It was a product that HP ended up buying. And it does a lot of analysis, and it also does security analysis as well, like security issues. It's really good. A gentleman was telling me that it's used in the government industry a lot, apparently, for security analysis, which is good to know. So yes, there are plenty of other tools. Again, can't cover them all. Just showing you what worked for me and why I did it, because they were cheap. Okay, so these are all the ingredients for a cake. Let's talk about how we throw them all together to bake a cake, right? A tool by itself won't do anything. A hammer by itself is not going to build me a house. But I can use a hammer, and if I learn to adapt to the hammer and use the hammer for what it's really good for, it can make me a whole lot more productive in building the house that I want to do, right? So I'm calling this workflow, right? I mean, think of this as recipe. Think of this as like, how do we tie all these disparate parts together, right? So the key thing is let's all integrate this with the CI server, with the continuous integration server. So upon every check-in to our version control system, my teams were using Perforce, Version, Git, whatever version control system you have a check-in trigger so that with every check-in, either it triggers a build or Jenkins checks every 15 minutes, say, and asks the repository, have there been any updates in the past 15 minutes? If so, I will trigger a build. That way, you can work with version control systems that can't do triggers, right? Older version control systems that can't automatically kick off an external process. You can work with them by having an external polling, asking the version control, have there been any new check-ins since this last time, right? Anyway, that way you will get, within 15 minutes, which is an ideal time, or whatever time works for your organization, you will get a build that happens within 15 minutes of a check-in, right? Either it's triggered automatically with every check-in, or it's triggered within an X number of minutes after a check-in, so that effectively every new check-in gets a build to get analyzed. So what's the build going to actually do? This build, which I propose making separate from your normal builds, this build is a static analysis build. It's going to compile your code. It's going to compile your tests. It's going to run your tests, okay? And I specifically recommend having your unit tests separate from your integration tests, right? And by that, I mean actually separate, like separate naming and separate packaging, and actually separate in Maven, like a Maven POM, so that when you run Maven test, it runs your unit test. When you run Maven validate, it runs your unit test and your integration tests. Anybody want? I can show you that later. So please feel free to raise your hand when I'm there, and you can, and I'll show you how I set that up. So, yes.
So I do have a question from the audience. Yes. So what about the long-running tests and the whole fast feedback cycle?
Thank you. Great point. So the question was, somebody in the audience asked, what about long-running tests and immediate feedback? That's a wonderful question. The concept that I'd like to stress to you is we are looking for rapid feedback. Fail fast, right? Again, The faster we identify an issue, the cheaper it is in terms of development time, development cost, and also the less the developer has to context switch. If I'm still working on the particular class file and I get a message saying that I checked in a bug, great, it's not as expensive for me to context switch as opposed to an hour or two later when I'm on a completely different class or a completely different package or a completely different project, right? So yes, absolutely, what we want to do is try to get the CI build within minutes, if we can. Ideally, try to give feedback to developers within 10 to 15 minutes, if we could, of a check-in that the developer has made. If that means that when you're trying to set this up for the first time and you see a test taking forever, I will suggest to you that maybe you either skip that test, or I would suggest to you that's clearly not a unit test. Right? A unit test is a test of just one particular class, one particular piece of functionality. I would be very surprised if you have a long-running test and it is a unit test as opposed to an integration test. What's the difference? An integration test is a test that involves not just one component. It involves calling a method into that component maybe, but then that method going out to call a database or calling a REST endpoint or making an external call into Alfresco or doing anything else, reading from the file system, doing something that involves something outside of the unit. That's not a unit test. That's an integration test. Those are great to have, and I suggest putting them later on in your pipeline for a continuous delivery setup, as we were talking about before. Like, having that as a gate, like all your integration tests, which take longer, have to all pass before you go deploy to staging environment or something. So yes, I would suggest that if you identify a test that is taking a long time, rip it out of your continuous integration build, take it out. It's obviously not a unit test. Take it out, put it as part of an integration test, and then have that not be run as part of your continuous integration. Thank you. Any other questions, by the way? If you have any questions, please hold up your hand. Please shout out. I'm happy to take your questions at any time. Okay, so back to what I was saying. We want this whole workflow, this whole recipe that I'm talking about, we want it to be as quick as possible. So just like we were talking about a long-running test, if you also have, because for most of us, if we go and try to implement this, we're not going to get a super fast, multi-core machine that nobody's using that they'll say, here, please, feel free to throw a long-running test on this, or feel free to use this for whatever you want. Most of the time, we'll have to use a hand-me-down service or a hand-me-down server, very old server, maybe a VM on an existing box of VMs, right? Or maybe we'll have to run it on our own box. My point is, we probably won't have super fast hardware, right? And we probably then will have to adjust what I'm telling you to the realities of the resources you have. So the point would be, let's first get something working. Maybe it doesn't test everything. Maybe it doesn't run all the tests or all the types of tests, just something. And then show to our management chain, hey, here's the value. Now can you give me some money for a server? Can I get a server? Can I put something in the cloud? Can I actually have the resources to do more of the testing? Because as I said, machine time gets cheaper over time. We want to demonstrate the value, then it's a lot easier to jump the hurdle of getting the resources we need. Okay? So I'm just telling you the ideal scenario. Your mileage may vary. Feel free to adjust as needed. So let's go back. The check-in triggers a build. The build will compile the code, compile the tests, run the tests. And by tests, unit tests, not integration tests. Unit tests. We want fast feedback. Then the build runs all the static analyzers via Maven Plugins, right? Remember, you can run these analyzers in the command line. You can run them in IDEs. We're automating it though, so we want Maven Plugins that wrap these analyzers, analyze our code, and they generate output. All of them that I'm talking about generate output in the form of XML files, which are wonderful, but useless for our purposes because they're not really human readable. I mean, human readable, yes, but not really user friendly. Then the static analyzers generate these XML files in the form of prioritized reports in the form of these XML files. And then we're going to use Jenkins plugins to then take these XML files, take these reports, and present them in a user-friendly format, right? Instead of wading through dozens of XML files and trying to find a few high-priority issues, we let these tools do the work for us because, again, machines love to do boring, repetitive work. So machines are begging for this. Let's let them do it, right? So the Jenkins plugins report these graphically and capture the trends over time, right? Now, that by itself is all great, but that's just a hammer. And a hammer by itself will not build your house. This is a tool. You set up the tool, but it's still not going to do anything until you change your process to use this tool to help you do what you want to do, right? And so that means the team then has to monitor these reports. So these plugins that I'm telling you about in Jenkins, they can all be configured that if any new issues are found, either the person who checked in the code can be emailed, or the entire team can be emailed, or any subset of that could be emailed, so that everybody knows right away, hey, there was a new issue that was discovered. Let's not make it worse, guys. Let's fix the issue right now so that we don't check in any bugs into our code. The team needs to monitor these reports and these trend graphs so that over time, hopefully when these issues are plotted, we see the trend graph going downward. We see the number of issues being fixed over time. We see our code coverage going up over time. We see the coverage, the amount of our code that's covered by our unit tests increasing. We want to see the issues decreasing, right? And that takes a team commitment, right? They just can't be one person who's a babysitter, who's a nag, and has to say, hey, did you fix your issue? No. It requires the entire team to buy in, to understand that everybody is responsible for making the code better. It's not just one person's job, it's all of our job. It's all of our duty to help do continuous improvement. Now, any new issues that are found must be fixed in that iteration, right? What that means is, if I'm working on a piece of functionality and I've introduced a new bug, that's my priority. That is my drop everything, fix my priority. That is my priority to do. I don't let the iteration continue introducing new bugs. Why? Because if I do, then I've made things worse. And we want to do the opposite. We want to continuously get better over time, right? And then extant or existing issues are then handled by working hand in glove with QA to create either a story or a defect and putting that in the backlog, right? If you're familiar with Agile processes, if you're not, story is a user story. It's a piece of functionality that doesn't exist that we want to exist. A defect is a piece of functionality that is not working the way we wanted it to, right? That's the difference between a story and a defect. Story, new functionality. Defect, existing functionality is broken, right? So that's how we would do it. We would use a story or defect to capture these issues. So every issue that is identified by our tools will be wrapped in a story or a defect and placed in our backlog in prioritized order. The team would then continuously pull from the backlog in priority order. Ideally, like to go back to an example at HP, when I first set it up, we had 743 issues, high priority issues. And I made it my mission with my management buy-in to tackle these one at a time. And within 2 releases, got the 743 high priority issues to 0, right? We were able to do that by, again, continuously pulling from these issues, pulling from the backlog, and continually improving our code each time. That is a change to our development process. That means in addition to every developer saying, okay, what new piece of work am I going to do? You know, what new functionality am I going to fix? Or what new things am I going to do? We have to also pull from the backlog a Kaizen story, a continuous improvement story, or a Kaizen defect, right? We're always going to be pulling in every iteration a story or a defect that will result in an improvement. So, in addition to functionality, we are also improving. And I would say this, right? We have to do the Kaizen story first. We have to pull that first. Why? Here's the analogy. Imagine if you decided to go through life saying, oh, you know what? I really have a finite amount of money, but I have a lot of things I'd like to spend my money on. And at the end of the month, if I have any money left over, I'll pay rent. Imagine if that was your attitude. If you had any money left over at the end of the month, I'll pay my electric bill. Guess what? Very quickly, probably by month 2, month 3, you'll be homeless, right? Meaning that you cannot leave this for the last. You have to tackle it first. It's kind of like the best practice for retirement. You have to set aside money for retirement immediately, and then with any remaining time, focus on spending your money on other things. Because if you wait till the end of the month for extra time, you will very rapidly never have that extra time. If I wait until the end of the month for extra money for my rent, I will very rapidly have spent all that money before I get any money for rent. So, to properly do continuous improvement, we have to change our process. A little bit of a mind switch that we are not going to do functional stories, functional defects first, and then if we have time, we're going to pull a story from the backlog and do continuous improvement. If we do that, we'll never make progress, because new issues will be adding up to our pile faster than we can ever pull them down, meaning our code, our tech debt will only grow over time. So again, a hammer by itself won't do it. We have to change how we code change our process in order to make it better, right? So it does require a change, and it does require some buy-in. But what I suggest is to make it go down smoother, take quick hits. Take some high priority issues that are identified that don't take more than, say, an hour or two to fix, right? And show the value. Show that your tech lead, or show your manager, show your team the value that, hey guys, in addition to the story that I was asked to work on, you wanted me to add a new checkbox here. Well, I did that. But in addition, I also fixed a memory leak issue. I also fixed a code stability issue, right? And you show them, and that gets them excited, hopefully. That gets them excited and understand the value of continuous improvement, to the point that eventually you'll get to become an improving organization where you tackle these improvement stories first, where you improve first, add on later. That's the key. All right, next, the leads and the management will monitor the quality metrics, because managers love ways to manage, right? They love extra metrics. They love to say, hey, I now have quantitative, not qualitative, I have quantitative means to measure the performance of my team. I don't just have to justify my budget request by saying, oh, my team did something, or my team has 5 people, and sure enough, we work 40 hours a week. Instead, you can say, here's exactly how many lines of code we have, how many classes we have, how many bugs we had, and here's how we decrease the bug count, and here's how we increase the code coverage. Actual numerical, quantifiable goals, which are helpful for your career, ladies and gentlemen, and also your manager's career. Always great to help your manager improve, to help you improve as well. Okay, and then the retrospectives. At the end, I believe somebody was saying that their process of continuous improvement has, at the end of an iteration, a retrospective where the team talks about what went well and what didn't go well. That's great. Let's continue that. But let's incorporate our learnings from these Kaizen stories, from these Kaizen defects, and let's incorporate that, and let's share with the team what we learned so that the team gets better. As an example, if the static analyzer found, this actually happened, static analyzer found in one of my teams that somebody was using a new integer, right? Instead of integer.valueof, right? And the analyzer flagged, hey, you're calling new integer. That is instantiating a new class. If you instead did integer.valueof, valueof is a static method, therefore you don't have the expense of class instantiation. You get the same benefit at lower cost. The team learned from that. Everybody learned, even though one person worked on it, by sharing that knowledge that the analyzer triggered, everybody learned from that. Okay? Now that's maybe an easy example. You're saying, oh, that's silly, but that's just an example of the learnings that we can all get and we can all learn from. Because no matter how senior you are, I guarantee you there's some things that we don't know, and it's really helpful to have the diverse tool sets show us and help us improve. This again results in us becoming a constantly improving, constantly learning organization. And remember what we said, that's our competitive advantage, because our competitors are doing it, or if they're doing it or they're looking to do it, we need to do that so that we stay ahead of them. All right, so I want to tell you the story of fun with system exit. This was, remember I was saying how it's good to convince your management chain. So I came back from Java 1, I believe it was 2008, and I spent late nights and weekends for at least a good month, maybe a couple months, working on setting up the system that I was talking about. And I demonstrated it to my manager, and I showed him a prioritized list of issues. And my manager, he was a coder in the past, but he wasn't a Java coder. So, I had to explain to him the significance of what I had showed him. And so what I showed him was a piece of code that had a condition, if some condition, and it looked like it was copied and pasted from a magazine because the comments on there were referring to a particular page. So we think that a contractor, looking at the version control history, contractor 5 years ago had checked in something, probably copied and pasted from a web page. And it said, if condition, a bunch of comments, system.exit, all right? And I asked my manager, you know what this is? He's like, no. And I was like, all right. And I explained to him, system.exit basically tells the Java VM, let's shut down. My manager's jaw dropped. He said, oh my goodness. We've actually had occasions when our system in production shuts down with no logging, and nothing logged to the database, no errors being shown on console, nothing at all seems to be causing this. No memory leaks, nothing in our profile that shows what's going on. It just seems to shut down. And I said, well, I can't prove that this is why, but I can prove that after I took it out, we have one less case where this could be happening. Sure enough, that particular situation of the thing just shutting down without any sort of warning never happened again. And that was important at the time because the project I was working on was a very, very high availability project for HP, and we were told we could not go down. It was very mission critical. And so by removing the opportunity for system.exit call to be called, we helped create a more higher available system. And my manager was delighted because we were not having these mysterious errors, which nobody wants to explain to a higher up why your system is just magically collapsing. That's a horrible situation to be in. You no longer have to explain that. More importantly, you can now show that we are a learning organization. We've implemented a set of tools and the processes with those tools to be able to identify issues like this from our existing code and keep issues like this from ever being introduced in our new code, right? So he was overjoyed. That sold him. I got clearance to set this up with HP, and we kind of were helping to institutionalize it through through many other teams there. So I call that fun with system.exit there, right? So just to summarize here, before I go to the demo, the topic again was continuous integration, not by itself, but using the set of tools that we were talking about and possibly other tools, along with modifying our processes to use these tools yields continuous improvement. So I wish you all a happy success there. If there are no other questions, I'll go into a brief demo. All right. Okay, so thank you all for your patience. And so this demo that I'm going to give you is a canned demo, right? Meaning it's not a setup so that it's using all the plugins that I listed, right? And it's not set up so that it's a really big software project like would be common in our enterprises. It's instead a canned project that I chose that is buildable within the time frame of my talk as a legitimate demo. I didn't want to do something that would take like an hour to build. If your code is something that will take an hour to do a build, or because it's just that complex and you want all these, then you can do what I did, which is have one build that is continuous, that triggers, that runs quickly and just runs the plugins that are quick to do within a few minutes. And then nightly, set up a different job that runs nightly and runs all the long-lived tests, all the integration tests, all the other analyzers that take longer time. Like anything more than an hour, you probably want to do nightly, so that your nightly can do the trend graph and your continuous can show you the issues right away that you might have accidentally introduced. Okay? So again, I'm going to show you the tools that I had described. These are not the only tools out there, right? There are many other tools. I just want to show you the ones that I've just used. So here's what Jenkins looks like. Jenkins, as I mentioned, is a CI server that has the largest market share in the industry. It's really cool in that it is a WAR file, right? You can drop it into a servlet container like Jetty, like Tomcat, within JBoss, WebLogic, WebSphere. You can also run it at the command line. You can say java-jar jenkins.war, and it'll run its embedded Jetty container and give you your interface right here. The great thing about Jenkins is that it's, again, just one file, right? A WAR file, and all its configuration, more or less, is through the web-based interface, right? For most things, almost everything you can do from a web-based interface. So this is Jenkins, and here's a nice butler, right? A nice British butler that Kosuke created. And in terms of managing Jenkins, you might recall I mentioned that there are these Maven tools, and then there are these Maven plugins, and then there are these Jenkins plugins that take the reports and plot them in a friendly way. And so these are the Maven plugins that, the Jenkins plugins that I've installed. Like Active Directory if you want to incorporate your users with Microsoft Active Directory if you use that at work, for security. Check style plugin if you want to, check the style of your code using the check style. Cobertura if you're going to use Maven Cobertura plugin. In my demo, I'm not going to show you Cobertura. In my demo, I'm not going to show you check style. They just take too long, okay? You can do them. Imagine, it's going to be a similar concept in terms of the issues found. You don't have time to do that. DRY stands for do not repeat yourself. So CPD, the copy paste detector, generates reports of duplicate code. Dry takes the reports that CPD generated and puts that in a nice duplicate code graphical view in Jenkins, right? Let's see, find bugs, right? It takes the reports from the find bugs folder, Git client, of course, plugin, and so on. So anyway, the point is there's lots of plugins, as you can see, Gradle. So the other advantage of using Jenkins is because it's so continuously developed. I mean, I upgraded my Jenkins just a couple days ago, and you can see there's already a newer version of Jenkins out there, right? So there's new versions of Jenkins that continuously come out. There are new versions of plugins that come out. The chances are, if what you're doing is, if the tool that you use is somewhat popular, somebody will probably be working on it and delivering a plugin. If the bug that you found is reported, chances are somebody will be working on fixing that. That's the benefit of having something that's highly used, right? So you configure Jenkins. Again, I'm not going to go too much in depth into Jenkins specifically. Just wanted to show you whatever tool you use, you will do something like this. Okay? So you configure Jenkins in this case, Maven repository, any environment variables. Do you have any system clock formats, any URLs, right? GitHub, do you have any GitHub servers, right? Any global configuration. So you can tell just for this demo, I haven't filled any of this stuff in. Obviously, you would fill a lot of this in, the SFTP server, so that Jenkins can email you, hey, dummy, you just checked in a bug, you want to fix that sort of thing, right? So these are all, again, various configuration things that you can do. You can tell it depending on if your build machine is not that powerful. You can say throttle builds. I don't want more than one concurrent build. Or if your build machine is powerful, you can say I'll allow 4 concurrent builds or whatever you want to do. The general guidance that I've gotten from talking to people who have done a lot of this is as many concurrent builds as you have CPU cores. Okay, rough guide. Obviously, just a rough guide based on how heavy your particular builds are. Okay, so let's take a look at how I've configured a particular project. This is the Apache Mahout project. It's part of Hadoop, part of the Hadoop family of projects. What it does is not really important. I just was looking for an open source project on GitHub that I could download and compile and actually run my analyzers against. Okay, so let's take a look at a couple of things. Let's take a look at how we configured. Let me open this in a new tab. Let's take a look at how. Oh, actually, here's the GitHub. All right. So Apache Mahout is on GitHub, right? So meaning it's using the Git version control system. GitHub is just an online repository where multiple open source projects are stored, and these are the project files for it. Let's take a look at the POM, right? So if you're not familiar with POM, Program Object Module, is how Maven projects are configured. So again, I don't want to get too much into how Maven works with the POM. I just want to show that no matter what tool you use, you'll do something like this. Remember, analyzers are tools that are run at the command line. They are wrapped by people who've done IDE plugins, so that within an IDE you click on something and it runs the tool. They're wrapped in this case by people who've written Maven plugins that wrap that functionality that are then integrated in your Maven build. How are they integrated? In this case, here's the example. So for Mahout, the people writing the Maven POM have already integrated this. Notice that they, in their reporting section, meaning we're not doing this as part of the build, we're doing this as part of the report. If you specify the Maven goals, then we see the Maven check style plugin is called, and they have defined this. This is a variable. This is how you define variables in Maven, right? This variable is defined earlier up above, so they only have one section to define all the versions and so on, right? And then you notice that they have their own configuration file. They're telling it, here's the configuration file. Here's how you use it. For test coverage, so they're not using Cobertura, right? Another one is Emma. They're not using that. They're using one from Atlassian. They're the people who've written Jira, right? SourceTree, you like them? Yeah. So yeah, Atlassian is actually a rare example of an Australian startup. They just went IPO recently, and they're really happy in Australia that they have a homegrown success story. So more power to Atlassian. They make some really good software. Atlassian has a plugin called Clover, right? But Clover, I didn't use. You know why? It needs a license, right? I didn't have a license at that time. I don't know, maybe the Mahout people got a free open source license from Atlassian. Maybe that's how they did it, right? But I didn't have one, so I couldn't do it. But you can see how they have their own license file, their own configuration parameters. They're telling it, I want you to run Javadoc. They're telling it code duplication, right, with PMD. And so they're telling it to use PMD, again, with any configuration, right? any code tags, and here's find bugs, right? To find bugs there, any configuration parameters there. Anyway, this just goes on and on. That's how you would do it. You basically just define a plugin, you put it in the reporting stanza for Maven, and then when you build it, you activate the plugin by specifying the Maven goal on the command line. Let's see how you do that. Any questions so far? Okay. Again, you would do the appropriate behavior in Gradle or Ant. Hopefully nobody's using Ant, but you would be doing something similar there. All right, so here's how I created it. I gave it a name. I called it Apache Mahout. I told it discard old builds, right? Keep 3 builds, right? That way we don't have it growing without bound because I didn't have that much space on the system. I gave it the URL to the Apache Git, right? So to do that, I just went here and right here. I just chose that, copied that URL. That's the URL that I tell Jenkins. I want you to get it from here. And then I tell it, here's the repository, no credentials because it's anonymous. If it wasn't anonymous, I'd have to put in the username or password, my own certificate, public key, whatever it is to allow access. You would add the credentials here. You can see that right here, right? Username and password, SSH, secret file, that sort of things. All right, next, what branch do you want to build, right? By default, master, but if you have a particular branch. So that's something to keep in mind. If you are using long-lived Git branches, not a recommended practice, but with Git flow especially, you might be using long-lived branches. In that case, consider building a separate CI job for every branch, all right? That way, it's not just people on one branch who are getting the benefits of seeing the continuous integration issues. Next, build triggers. When should we build it? Should we build it whenever a snapshot dependency is built, right? Should we build it remotely? Like, for example, a gentleman was asking me, I have a system where I want the system to run, but not when code changes, but when I checked in a change to a database SQL script. So there are many ways to do it. That's one of my mottos, right? There are always many ways to do it, more than one way to do it. Here's an option. The same script that checks in the SQL file can, for Jenkins, for example, can call a REST endpoint that triggers a build. Okay? So that's one way to do it. So that way, in one command, you check in the file, if the check-in succeeds, then you call the REST endpoint using curl or wget or some other command line tool that just issues a URL call, and that triggers the build. Okay? That's one way to do it. So that's one way to do it. Trigger builds remotely, right? Build what other projects are built. So for example, you were talking about pipelines, right? So when the parent or when a predecessor project is built, then you kick off this build. So that's the way you can chain pipeline elements together. Build periodically. I don't care. I want it to be built every hour. Maybe that's your choice, right? Build when a change is pushed to GitHub. This is what I do because the machines that I've had have never been fast enough to build every single time a check-in happens. And also, I've usually been on big teams where if I were building every single time a check-in happened, the machine would be continuously building, and we wouldn't be able to use that machine for anything else. So what I do is I give it a schedule. And the way I do it is I usually do this schedule. So this is in the format of cron. If you folks are familiar with the cron command, that's a Unix system invented by Paul Vixie cron. It's a system by, as the name implies, setting up periodic jobs, right? So in this case, by capital H divided by 15 says every minute that is every hour that is evenly divisible by 15 at, and this is the day of the week, month of the year, and so on, right? So 0722 as an example. I want you to do this, right? So I can just copy this, for example, right? And then paste it in here. And whoops, wrong one, I didn't copy it. But anyway, if I pasted it, that would be in this format, minute, hour, day of month. What that would do is, at every 15 minutes, if that was what I did, or every hour, whatever period I chose, it would pull the version control system, Git, in this case, and it would ask, oh, by the way, has there been a new check-in in the last 15 minutes? If no, no problem. I'll check back in with you in 15 minutes. If yes, I'll kick off a build, right? That way, we guarantee that within 15 minutes of any new check-in, we're starting a build. It also guarantees that we're not continuously churning the machine unnecessarily by doing builds with each check-in. So we at least get some grace time, right? So that's that one. And then, if you have the time, if you have the performance, delete the workspace so you start clean with every build. Abort the build if it's stuck and so on, right? Pre-build steps. But here's the meat of the issue, right? Here's how we call the Maven plugins. So in this case, I'm calling PMD. So the way Maven plugins work, if you're not familiar with plugins, you mention the goal and then a particular target, right? So I'm saying I want the PMD plugin to be called and I want it to execute CPD, the copy paste detector. The next thing I want to do is I'm calling the same plugin, PMD, excuse me, but now I want it to run PMD, which is the actual static analyzer. And I'm calling the find bugs plugin, and I'm asking it to run find bugs. Each of these plugins, you can go to their usage page, they have a whole bunch of different targets you can call. Some of them are interesting because they not only run the analysis, but they can fail your build. They can fail your build if, and this is configurable, if any new issues are discovered. They can fail your build if, excuse me, a certain number of issues are discovered. They can fail your build if a certain number of high priority issues above a threshold that you set are discovered. That's all configurable, up to you. Excuse me. Especially useful for continuous delivery, where you want to have automated systems, right? Saying that only if it passes this threshold do I allow it to go into the QA environment. Do I allow it to then get deployed to the staging environment? And then ultimately, through continuous deployment, right? Continuous delivery, where they say automatically get pushed to production. But before we get there, we have to meet these goals. And by doing that, you can by choosing the appropriate goal, you can fail the build if you want it. Yes?
So how would you do like a Gradle?
I'm sorry?
How would you do this with Gradle? Because I don't see options, I just see the home file.
Right, well, you don't see that because I've chosen Maven, right? So I've chosen Maven for this particular project because this is a Maven project. But if I were, here, let's leave this
That's
page.
okay. I believe you.
So if I wanted to create a new item, right, we could create an external job. And I don't know if I'd have the Gradle plugin configured, but we would actually see it as a specific option or an external job, and we could say that I want to use Gradle as my build engine, or Ant as my build engine.
And it would be similar to the way you target the tests?
It would, I'm not that familiar with Gradle, but it would be, you'd have to have a Gradle file equivalent to a POM that tells it what you want it to do, and you would have to, in Gradle, configure the plugins, hopefully they exist, for the analyzers you want to run with the parameters you want, and hopefully Jenkins plugins exist to read the Gradle plugins output file formats in such a way that they can be integrated and display the results. I know it works for Maven and Jenkins. I don't know if it works for Gradle, but it is getting more and more popular, so I wouldn't be surprised if it isn't. So I guess the answer is maybe, but further research is necessary. How about that?
There is a find bugs plugin with Jenkins too, so you can just create that Jenkins find bugs plugin.
I believe you said there's a Jenkins find bugs plugin. Yes. In fact, let me show you. We're actually making use of that Jenkins find bugs plugin. So this part is the Maven portion, right? Maven is doing our build and calling these Maven plugins to analyze our code. You would be doing a Gradle build and then calling Gradle plugins to run the analyzers to do it. Okay? So that part is done. Now we need to run the Jenkins plugins to take the output of our build engines and then plot them nicely. Here's how we do that. So I now have build settings. I say publish find bugs analysis. That's the Jenkins find bugs plugin. I'm telling it publish PMD analysis, publish duplicate code analysis, right? So you can see all that. And again, this is the minimum number of duplicated lines for high priority warnings. So I can say anything above 10 lines, I want that to be a high priority. We got to refactor that. It's up to me, but this is a default. 50 lines for high priority, 25 for low priority or normal priority. Open tasks. Scan workplace for open tasks. This is a Jenkins plugin that has no Maven equivalent because it's just Jenkins just analyzing our source code. What it does is it scans any files by default to star.java, but we can say a specific set of files we want to include, specific set of files if we want to exclude them, and then we choose what we want to search for. In this case, I said high priority is fix me, normal priority is to do, and low priority, I don't know, I could say XXX or look at this or whatever it is, right? The point is, this looks through all of our source code. Anytime it finds one of these tokens, if it finds a fix me, it says, I just found a new high priority issue. If it finds a to do, it says, I just found a new medium priority issue, right? So that's the value there. And I tell it ignore case, so that uppercase to do is the same as lowercase to do. And then publish the combined analysis with all my warnings. So let's take a look at how that would actually work. Let me go into Jenkins and let's actually kick off a build, right? So for those of you who've seen Jenkins, you can see how we're actually doing it. For those of you who haven't, it's kind of cool. You can actually watch the thing be kicked off and monitor the console output. It's kind of nice. So you basically can see the command line output, shown in an infinitely scrolling web page, which is kind of nice. So, and the console log is archived, so you can go back to a build, especially a build that failed, and you can see what exactly caused, what was logged on the console when it died, or what caused the failure. So it's really helpful there. So again, I'm not showing you every single plugin that I recommended. I'm not showing you all the plugins that are out there. I'm only showing you a small subset that I can reasonably get done in this presentation. Okay? So you can see that we quickly got the results. Now I'm going to go back to the main page, and you can see the output on a trend graph. Again, canned demo, so the output that you're seeing on the graph are all straight lines. In real life, these would be different builds, so you'd see the graph having different values over time, right? So use your imagination. Let's pretend that these are graphs that show different things over time. So duplicate code trend. This is a DRY plugin showing you that there are 239 low priority duplicates, meaning code that is less than 25 lines that are duplicated. These are 123 pieces of code that are 25 to 50 lines that have been duplicated. And this, high priority, 41 examples where we have 50 or more lines that are duplicated. Wow. So I would say as a developer, I would really want to be taking any 50-line chunks and refactoring that into a common utility method or a superclass, or think about a different way to do it. Maybe we don't need the duplicate, right? So that's find bugs. That's DRY. Open tasks. These are examples of to-dos or fix-me's, right? So in this case, it turns out there were no fix-me's. All right, that's good. So my code, this project doesn't have any fix-me's, but you know what? It has 84 medium priority, which is the to-dos. Oh boy. Well, we should probably try, maybe writing stories for those and fixing those, right? PMD. Remember a static analyzer PMD? Good. No high priority, but it did find 93 normal priority issues, right? And then I have one an analyzer plugin that's just the trend for all of them. It consolidates all of them. So it consolidates the open tasks, the to-dos, the fix-me's, the find bugs issues, the PMD issues, the if we had code coverage, it would consolidate that as well, right? The duplicate code and so on. So let's actually take a look at what these look like, right? So notice how it's broken down. It's really helpful, I think. You have high priority issues, normal priority issues, low priority issues, right? And it's broken down by each Maven module or by package, right? You can see the issues. And by the way, it's broken up instead of red, yellow, green for high priority, medium priority, and low priority. They use red, yellow, and bluish because they don't want green to symbolize everything's great. They want to show that you still need to fix it, right? So that's what red, yellow, blue means. These are the files that have issues. You can take a look. Hey, you know what? If I fix this one file, sorting.java, I could take care of 79 issues, including quite a lot, 16 high priority issues in one file. So that's a great value, right? That's an example of what I'm saying. This is a quick hit. You can show your team or your lead or your management chain, hey, just by spending an hour or two on this one file, I managed to improve our code quality, and not just by a subjective amount, but what this machine is telling me in a quantitative fashion I've been able to do, right? So examples there. Now, what are the categories of errors, Like basic errors, code size, like 43 is too big, right? Empty code, we have empty code blocks, right? Import statements not being used, Java logging not being properly done, optimization or unused code. Let's take a look at what one of these might be. Again, I'm not going into all of them, I just want to show an example. So let's take a look at these warnings, right? So it's saying that in this particular file, there is an error. Well, what's that error? What does that mean, right? Something to do with a particular file. Let's click on it. It shows me the actual class and the actual line of code. Well, what's the problem? I move my mouse over it. It tells me the problem and how to fix it. In this case, it's pretty straightforward. It's just saying consider using string buffer or string builder or string buffer instead of constantly creating a new string each time, because Java strings immutable, having the cost of instantiation and so on, right? So those are the details there. Let's take a look at. Let's go back. Let's take a look at some of the other types, right? So here are the actual types of issues, right? One particular one, which is I think kind of cool. I don't know about you, but a lot of times if you just let the IDE write your exception handler for you, it'll automatically insert this, and if you forget to do something, you'll leave this in there. Well, now you're not going to be allowed to forget, because the analyzer will catch this and tell you, hey, you're printing the stack trace. That's great for console, but it's not going to be in your logs. It's going to be lost, right? And you probably want to do more than just logging it, so that's kind of nice, right? Other things. Let's take a look at duplicate code. Duplicate code can help. Let's pick a file with a lot of duplicate codes. Okay, let's look at sorting.java. We were talking about that before. Okay? So sorting.java, it's got a whole bunch of duplicate code. So here you go. These 25 lines of duplicate code are duplicated in, and it tells us the exact lines in each file, in this case the same file, where this code is duplicated, right? Clearly, an example where a developer copied and pasted instead of calling a method or refactoring into one common method. And remember, great opportunity for code improvement that's automatically found, right? Let's take a look at maybe one or two others, right? Let's see. I like this one. All right, so here in dense-vector.java, what's the problem here? So this code, this for loop could be simplified into a while loop. So we have a for initializer, condition, and incrementer. But really, the only thing we've defined is a condition. Well, that could be simplified to a while loop, which not only has fewer lines of code, it's also easier to understand and easier to follow. Remember, as a coder, we always want to follow the principle of least astonishment. The person who comes after us should not be astonished by our code, unless it's by brilliance, but they shouldn't be astonished because it looks crazy, right? So even if it makes sense to us, I guarantee you in 6 months when I come back to this, I'd be like, hey, why was I doing this here, right? So it's always a good idea to choose a simpler way to do it, and now we have a tool that will show us. Just one or two more before I end. Let's go back. Same package. Oh yeah, a common error that I see a lot of times that I've been guilty of certainly as well, which is if you override an equals, you better override hash code. If you override hash code, you better override equals, right? Don't just take it from me, Josh Block, author of Effective Java. You listen to him talk or you read his book, he tells you the same exact thing. We're not going to go into the details, but just Google why override hash code or why override equals in hash code, and you'll see plenty of examples of why that is. And there are actual examples of why a map, why one of your maps or collections might be broken for looking up objects or for inserting duplicate objects if you override one without the other. Well, now you don't have to worry because this tool will automatically find these issues for you. So again, the point is, this is a hammer. How are you going to use it? By creating stories, by working with your QA team. So your QA team goes through and ideally starts off with, and again, initially it'll be you, but hopefully, ideally, the end goal is your QA team goes through and writes stories and defects based upon the high priority issues first. And you as a dev team start pulling from the backlog first these issues, reducing the issues over time, making the issues go away so that you have no high priority issues. That should be your goal. 0 high priority issues, then tackle the medium priority issues, and so on, right? First, tackle the code coverage. If it's a legacy project and you haven't ever implemented a code coverage tool, which I'm not showing you because we didn't have time, you will be shocked to see the low single digits of code coverage that a legacy project has. Ideally, let's aim for double digits. Let's aim for at least 50% code coverage, if ideally much more, but let's aim for that. Now you have that ability, right? So by institutionalizing this, by incorporating this as part of your development process, we can basically enable you to make use of the best tools that are out there to be able to automatically identify issues, prioritize them, and make it possible for a machine to do its job so that we can do ours and become a continuously learning, continuously improving organization. Questions?
Can you suppress the issue
Yes, you can.
directly from here, or do you have to?
What you would want to do is, I might have shown you in the Maven POM, each of the analyzers has configuration parameters that you can set there. A lot of them also have configuration files for more custom configuration. Things like you can tell it, I don't want you to inspect generated code. Because many times we have generated code, we provide like a schema or a WSDL and it auto-generates. I don't care if that has issues because I'm not going to be able to fix them anyway. Or you can say, a lot of these issues will be what the analyzer thinks may be an issue, but there's a reason why you chose to do it that way. Like, yep, it could be buggy, but I know it does not have a bug. Yes, you can tell it, ignore that particular issue for this package, for this module, or for this class. Again, each analyzer has different ways to do that.
So you have to go into the configuration file
And depending on the analyzer, yes, right? The best way to do it is run the reports first and find out the issues. And you'll find several of them will be false positives, right? Several of them will be issues that are not really issues. And you can then decide if it's distracting to you, yes, ignore that. Put a custom ignore in there. Anything else? All right, well, thank you very much. I do appreciate your attention. I was really happy to come and take the opportunity to talk to the San Diego Java users group, thank you all for your attention. And Paul has my contact information, which I think will be on the site as well. If you had any questions that you wanted to ask me about later, feel free to reach out to me. Also, as I mentioned, we were the raffle.
Yeah, we're going to
do the raffle, right? Yeah, absolutely. We're going to hand that over to Paul so he can do the raffle. But thank you all.